plain wall with heat generation, the case we discussed in the last lecture, and I also discussed a number of conclusions. There is one more case in the plain wall only when there is heat generation, but the two planes, the two sides of the wall are not maintained at same temperature. As you remember, in the previous case, we maintained the surfaces of the wall at constant and equal temperatures equal to TW, right? And whatever derivation I made, that was only with respect to that case. Suppose if the walls are maintained at a different temperature, one wall is at 120, one wall is at 60, and still heat generation is taking place, in that case, the temperature profile will be slightly different. Okay, it won't be symmetrical. C1 value will not be equal to 0. तो उस derivation को नहीं करेंगे because derivation के form में थोड़ा सा और complex हो जाएगा, है ना? But I will take a numerical problem based on that. So that we will discuss when I'm going to take the numerical problems all at once. So the fourth derivation, the fourth case is now the cylindrical coordinates. So conduction or temperature profile in a hollow cylinder. टेम्परेचर प्रोफाइल इन होलो मतलब आप समझते हैं होलो सिलेंडर, बिकॉज अगर मैं होलो सिलेंडर नहीं लूंगा तो दो सरफेस नहीं होंगे मेरे पास. सपोज इफ आई टेक अ सॉलिड सिलेंडर देयर विल बी ओनली वन सरफेस, आउटर सरफेस. If I take hollow cylinder, then there will be inner surface and the outer surface. So inner surface will be maintained at a temperature T1. Outer surface will be maintained at a temperature T2. So we can talk about heat transfer in this case. Right? So that is why I'm taking hollow cylinder. Okay. Obviously, in the hollow cylinder also, because we discussed about the general heat conduction equation in cylindrical coordinates, so that is also valid for hollow cylinder and also for solid cylinder. ये चीज एक ध्यान रखना, जो भी cylindrical and spherical, देखो wall में तो hollow wall जैसा कुछ नहीं होता है ना, no meaning of hollow wall, बना सकते हैं ऐसी ज्योमेट्री भी, बट नहीं होती. We have hollow cylinder and hollow sphere. Now the conduction equation of cylindrical coordinates and spherical coordinates are valid for hollow cylinder and solid cylinder respectively, and for hollow sphere and solid sphere the same equation is valid, right? So that is you must write. I will discuss that. So suppose that I have a hollow cylinder like this. hollow cylinder लेने के पीछे रीजन ये है कि मेरे पास दो सरफेस होने चाहिए. Okay, suppose I have a hollow cylinder. Okay, and of course, in the hollow cylinder also, I am assuming that heat transfer is taking place in radial direction only, because length is sufficiently large so that there is no heat transfer in the axial direction, right? This is the case, correct? If you see the cross section view, it will be a circle. ठीक है, अगर आप इसका क्रॉस सेक्शन व्यू बनाते हो, let's make this here only. The cross section will be circular. Okay. That is the cross section view, but there will be inner cylinder as well. So let's make this inner cylinder. There will be a smaller circle. Okay. Fine. Hollow cylinder, the inner surface temperature, this is the inner surface, it is maintained at a higher value T1 and the outer is maintained at a lower value T2. Of course, T1 is more than T2, just like the previous cases. T1 is more than T2. Here this temperature will be T1, this temperature will be T2. There is no heat transfer in the axial direction, means all the this cylinder is maintained at the same temperature along the length. Okay, so let's say that the length of the cylinder is equal to L. Right, what are the assumptions? First one, assumptions, हर बार की तरह यहाँ भी assumptions लिखनी है. First of all, steady state. Steady state means with time this surface temperature which is maintained at T2, this surface temperature which is maintained at T1, T1 is more than T2. Steady state, with time these temperatures are not changing. So steady state है ना? We have some kind of source, some kind of sink is there, so temperatures are not changing. Secondly, heat transfer in radial directions only, and there is no heat transfer in z direction and theta direction. Okay, heat transfer in radial direction only, radial directions only means we can neglect the temperature gradient in z and theta direction, right? It means no heat transfer in z and theta. अलग से नहीं लिख रहा, you must know. K is not a function of temperature. अगर मैं यहाँ पे K को temperature का function ले लूंगा तो derivation और complex हो जाएगी, ठीक है? So one dimensional, which is the radial dimension, steady state, K is a function of temperature, and suppose I have no heat generation. No heat generation. Now we have to find the temperature profile. Also, we have to find the nature of the temperature profile and the heat rate. And then we have to write the heat rate in the form of driving force by potential difference. Also, we have to find whether the heat rate is a function of x, or I mean not x, r or not. ठीक है, तो ये चीजें हैं. Please note that the heat is being transferred from inner of the cylinder to the outer part. The cylinder is made up of a material whose thermal conductivity is equal to K. Also, you can say that the inner radius, if this is your cylinder, right, then inner radius, this is your axis into the board, the inner radius is R1 and the outer radius is R2. यहाँ पे आपको फंडा देखना है. See, in many cases we have this hollow cylinder, like in the case of heat exchangers, the tubes can be considered as hollow cylinders, right? देखो दो चीजें होती है, hollow and solid. स्लैब के केस में होलो केसेस आपके पास नहीं आते जैसा मैंने बताया, बट इन केस ऑफ सिलेंडर एंड स्फीयर वी हैव होलो स्फीयर, सॉलिड स्फीयर, होलो सिलेंडर, सॉलिड सिलेंडर. In all the cases, whatever conduction equations we have derived, the respective conduction equations are valid. तो अगर मैं होलो सिलेंडर पे भी डेरिवेशन करूंगा, I can use the conduction equation और same conduction equation. और अगर मैं सॉलिड पे भी डेरिवेशन करूंगा, I can use the same conduction equation. ये बात क्लियर होनी चाहिए, ठीक है? So from where to start? This was my fourth case. From where to start the equation? Do you also know that if the heat is getting transferred in the radial direction, the area for heat transfer is not same at each value of R. As R changes, the area of heat transfer is changing. As you are going in this direction, the area of heat transfer is increasing. तो ये चीज मैंने डेरिवेशन में ऑलरेडी बता दी थी और उसी के हिसाब से डिराइव किया था. What was the equation? 1 by R del by del R. Let's write d by dr because now temperature is the function of R only. R dt by dr ये था ना, is equal to 0 because generation term is 0, so Qg is not there. Steady state is there, so accumulation term is also 0. है ना? Now we have to integrate this equation. For deriving this equation, I already assumed that area is not constant. That is why I was not able to take this R up. So this is not a constant area problem like a plain wall. But suppose if the heat transfer is taking place in axial direction, not in the radial direction, in the axial direction, the area for heat transfer will always be constant. Fine. So axial में होती है तो area constant रहेगा, radial में होती है तो area constant नहीं रहेगा. Obvious चीज है ना. अगर आप radial इस direction में करो, देखो यहाँ पे it will be this area, this area, this area. The area is, it is changing. Okay. So 1 by R. So this R goes here, becomes 0. So we have d by dr. So R dt by dr, that is the equation, R dt by dr is equal to C1. Right? Is it okay? R becomes 0. I have integrated 1, so that becomes R dt by dr. Right? And then it becomes C1. Fine? Okay. Then it becomes dt by dr is equal to C1 by R. dt by dr is equal to C1 by R. This is again one more very important, the rate of change of temperature with radius is inversely proportional to the increase in radius. Okay, the heat is being transferred from in to out. Now, if you again integrate this, T is equal to C1 by R, integral is C1 log of R plus C2. very important relation that in a cylinder, the temperature profile, is it parabolic? What do you think? It is logarithmic. So please note that logarithmic temperature profile, of course, I have to find the value of C1 and C2. Logarithmic temperature profile. So in a cylinder, the temperature profile in the radial direction is logarithmic in nature. For finding C1 and C2, again we have two conditions. At R is equal to R1, C is equal to, not C, at R is equal to R1, T is equal to T1, and at R is equal to R2, T is equal to T2. बहुत सिंपल से फंड है, बहुत सिंपल सी बाउंड्री कंडीशंस. ओके, समझ आ रहा होगा, कोई दिक्कत नहीं होनी चाहिए. दिस इज जस्ट सिंपल होलो सिलेंडर, आपने शायद कई बार किया भी हो. पुट द वैल्यूज. सो आई गेट T1 is equal to C1 log of R1 plus C2, and T2 is equal to C1 log of R2 plus C2. This is the equation. R is equal to R2, T is equal to T2. You can have various kind of algebraic methods to solve this and find the values of C1 and C2. Okay, तो एक बार कर लेते हैं. You can either try to subtract this. If you subtract this, then you have this equation. T1 minus T2 is equal to C1 log of R1 minus R2. So that becomes R1 by R2. ठीक है क्या? R1 minus R2, log of A minus log of B. Okay, so log of R1 by R2, and this becomes 0. So C1 is equal to T1 minus T2 divided by log of R1 by R2. Correct? That is the value of C1. है ना? Okay, so R is equal to R1, T is equal to T1. Okay, T1 is more. Okay, fine. R1 is less. Log of R1 minus log of R2. ठीक है. That is the value of C1. Put the value of C1 in any equation. Suppose in this equation you are putting the value, then you can get the value of C2 from any of these equations. Okay, so let us put the equation. How to find C2? C2 is equal to T2 minus either C1 ln R1 or C1 ln R2. Okay, T2 minus C1 ln R2. T2 minus C1 log of R2. Any of the equation you can use. Let's see what we are getting. So C2 is equal to T2 minus C1, which is T1 minus T2 log of R1 by R2 log of R2 by log of R1 by R2. ठीक है क्या? है ना? That is the value of C2. So we can try to write this equation. Let's see. So T is equal to, the temperature profile says C1 log of R, and C1 is this, T1 minus T2 log of R1 by R2, that is C1 log of R, ठीक है, plus C2. C2 is, I'm writing the second term here to have some space, T2 minus T1 minus T2, we can simplify this, don't worry, log of R1 by R2, log of R1 by R2 into log of R2. ठीक है, क्या कॉमन लिया जा सकता है? देखो, I can write this equation as T minus T2, right, is equal to, I can take T1 minus T2 common, T1 minus T2, अंदर क्या बच जाएगा? And even I think I can take this common, log of R1 by R2, log of R1 by R2. So T minus T2 is equal to T1 minus T2 by log of R1 by R2. This is log of R minus log of R2. So I think it should be log of R by R2. ऐसा कुछ बना है? नहीं बना, देखो. So I should have this equation as T minus T2 by T1 minus T2 is equal to log of R by R2 डिवाइडेड बाय log ऑफ R1 बाई R2, या आप इन दोनों को चेंज भी कर सकते हैं, R2 बाई R, R2 बाई R1। एक बार चेक कर लेते हैं, डेरिवेशंस देख लेते हैं, है ना। सो आई स्टार्टेड विद दिस इक्वेशन। हो सकता है ये फॉर्म आपसे कई बार गेट में पूछा जा सकता है, दे आर नॉट इंटरेस्टेड इन दीज थिंग्स, बट कई बार ये इस फॉर्म में आपके पास क्वेश्चंस आ सकते हैं, विच ऑफ द फॉलोइंग इज करेक्ट इक्वेशन ऑफ टेम्परेचर प्रोफाइल। कई बार आप ये देख के तो बता दोगे, बट ये रहेगा तो वहां आप कंफ्यूज हो जाओगे, ठीक है। तो ये डेरिवेशंस इस तरह से आनी चाहिए कि कैसे करनी है। ओके, सो आई सबट्रैक्टेड दिस इक्वेशन, T1 minus T2 C1 log of R1 by R2, C1 minus T2 0, so C1 becomes equal to T1 minus T2 by log of R1 by R2, correct। एंड देन C2 के लिए मैंने इस इक्वेशन का यूज किया, दैट इज T2 minus C1 ln R2, एंड C1 की वैल्यू पुट कर दी यहाँ पे T1 minus T2, ठीक है। सो T2 minus T1 minus T2 log of R1 by R2 into log of R2, and then T becomes equal to C1 into ln R, right, and then C2, then I wrote T minus T2 as this, and then T1 minus T2 was taken as common, log of R1 by R2 was taken as common, ठीक है। ओके, दैट इज द टेम्परेचर प्रोफाइल, T minus T2 बाई। इसके और तरीके भी हो सकते हैं, यस, आप थोड़ा बहुत इसको और मैनिपुलेट कर सकते हैं। आप इसको दिस 1 माइनस दिस कर देंगे, यहाँ भी 1 माइनस दिस हो जाएगा, देन देयर आर वेरियस वेज ऑफ मैनिपुलेटिंग द थिंग्स, बट आप इस फॉर्म में एक याद रख सकते हो। इसको आप थोड़ा सा याद रखने की कोशिश कर लेना कि हाँ सर ये याद रखनी है। ओके, दैट इज द टेम्परेचर प्रोफाइल इन अ सिलेंडर, होलो सिलेंडर। एक चीज पता लगी कि यस, इन दिस केस द इक्वेशन दिस टेम्परेचर प्रोफाइल इज लॉगरिथमिक इन नेचर। अब Q के बारे में बात करते हैं और dt by dr के बारे में बात करते हैं। ये सही है, द dt by dr is C1 by R, right? Means as R increases, and what is C1? C1 is where is C1? C1 is T1 minus T2 by log of R1 by R2, right? So yeah, log of R1 by R2, fine, ठीक है। So that C1 by R, what do you think? This dt by dr is negative or positive? What about C1? C1 is negative or positive? If T1 is more than T2, the numerator is positive, but what about log of R1 by R2? R1 is less, R2 is more, so R1 by R2 is less than 1. Log of something which is less than 1 is negative, right? It means dt by dr is negative. Fine. So what is the meaning of this? What is the aspect? What is the meaning? First of all, as the value of R increases, the gradient, the change, the dt by dr is going to decrease. Fine, that is one observation that you must know. तो कैसी प्रोफाइल बनेगी? ये लॉगरिथमिक बनेगी, ठीक है, एंड ऐसी बनेगी। अच्छा, लीनियर होगी क्या? इट इज नॉन लीनियर। लॉगरिथमिक मींस नॉन लीनियर, ये भी लिख लो, नॉन लीनियर ऑफ कोर्स। लेट्स टॉक अबाउट Q। Q के लिए क्या करते हैं? लेट्स सी, इस फिगर को मिटाते हैं यहाँ से, या assumptions मिटा देते हैं। हाउ टू फाइंड Q? दोनों तरीके हैं, यहां से भी कर सकते हो आप, बेसिक बैलेंस लगा के। सपोज देखो, आपको याद होगा हाउ आई रोट द कंडक्शन जनरल इक्वेशन बाय कंसीडरिंग ए स्मॉल एलिमेंट, राइट? वो स्मॉल एलिमेंट आप यहां पे भी कंसीडर करके फूरियर्स लॉ को अप्लाई करके यू कैन राइट द वैल्यू ऑफ Q। सेम थिंग है, एक ही बात है। हाउ टू राइट Q? Q इज इक्वल टू माइनस K A। नाउ A इज अ प्रॉब्लम with most of the student, you don't understand what is A. A, I told you from the very starting, is always perpendicular to the direction of heat transfer. Heat is getting transferred in which direction? Radial direction. In the radial direction, this area, this entire area, right? If this is the inner, this is suppose the part of the cylinder, then this entire area is available for heat transfer. What is that? The surface area. That is 2 pi RL or pi dl, है ना? So, which area I will write here? Q is equal to K into A, which is 2 pi RL, 2 pi RL, which are R1L or R2L, because area is not constant here. Area is not constant, right? So Ka dt by dr, how to write? There are various methods. Ka dt by dr, fine. So either I should write this as, okay, let me write 2 pi RL, correct, where R is changing, right? Because area can be anything, this R, this R, this R. I'll later integrate it, don't worry. dt by dr. ठीक है? Now let us write these equations. Q is equal to dr by R and dt. So I'll write this equation as Q into dr by R is equal to minus K 2 pi L dt, करेक्ट। इसकी लिमिट्स आप डाल दो, limits will be from, let's see, when R is R1, temperature is T1, when T1 is more, right? When R is R2, temperature is T2. Of course, this negative sign will take care of this lesser value of the upper limit. Fine. So this becomes log of R. So log of R2 minus log of R1. So Q into log of R2 by R1. Chalega. Log of R2 by R1 is equal to 2 pi KL. I can write T1 minus T2. A very simple derivation. यहाँ पे मैंने इस dt by dr का यूज नहीं किया, ये भी कर सकता हूँ. I'll tell you how. From here you can find that, ध्यान से लिख लेना, गलत मत उतारना, ठीक है. Q is equal to, I can write this equation in the form of the driving force, and then whatever is left, you can see here what is left, log of R2 by R1, log of R2, the bigger radius, by R1 by 2 pi KL. Please note that this is the resistance of conduction resistance in a hollow cylinder. Please remember this, R conduction. But for a cylinder, L by this Ka was the R conduction for a slab. This is the R conduction for a cylinder. You can easily write this equation like this. Now what do you think? In this Q, do you find anything which is variable here? R2, R1, K, L, you see that everything is a constant, right? It means, यहाँ अच्छा प्रोफाइल कैसी होगी? नॉन लीनियर. इट इज स्टडी स्टेट, प्रोफाइल इज नॉन लीनियर, बट Q इज नॉट अ फंक्शन ऑफ R. हाउएवर dt by dr इज अ फंक्शन ऑफ R. अगर आप इक्वेशन देखो, K into A, this A is continuously changing, but simultaneously, see, dt by dr, देखो होगा क्या? एरिया इज चेंजिंग, राइट? एरिया, इसको इस तरह से समझो, if you are present here, you are present here, you are present here, the area is increasing. But dt by dr is inversely proportional to R. So area is proportional to R and dt by dr is inversely proportional to R. It means that RR will get cancelled out and ultimately Q is not a function of R. This is very important कि Q is not a function of location here. Understand? Read on this. अच्छा, ये same equation क्या मैं यहाँ से ला सकता हूँ? देखो same चीज, same result आएगा. Q is equal to minus K 2 pi RL into dt by dr. What was dt by dr? C1 by R cancelled, minus K 2 pi L into C1. And what was the value of C1? T1 by C2. एक ही बात है, बिल्कुल सेम रिजल्ट आ जाएगा, तो दोबारा वो करने की जरूरत नहीं है. आपको हर तरह से रिजल्ट आना चाहिए, ठीक है. So Q is not a function of R. Q is constant, टाइम के साथ तो constant है ही. Q is not a function of R, that you must know. हर बार प्रोफाइल नॉन लीनियर होने की वजह से जरूरी नहीं कि Q कांस्टेंट हो, Q लोकेशन का फंक्शन हो. Q लोकेशन का फंक्शन तभी होगा व्हेन देयर विल बी हीट जनरेशन, जो मैंने आपको लास्ट एग्जांपल में समझाया था. वी विल डिस्कस दिस. आपको मैं हर केस में दिखा दूंगा Q इज अ फंक्शन ऑफ लोकेशन ओनली इफ देयर इज हीट जनरेशन. If profile is non-linear, this is not the sufficient condition so that we can say that the Q will be a function of location. If K is a function of temperature, again profile can be non-linear, but Q is same. We have proved it. यहाँ पे अब K को function of temperature मान के complexity नहीं लाएंगे, right? So how the profile looks like? अब मुझे 2D में बनाना पड़ेगा, ठीक है. ये प्रोफाइल आपकी जो होती है, ये suppose you have a cylinder. You have this cylinder, this is the, suppose there is one more, this is the hollow region. Suppose this is a hollow region, the temperature will be more. And it says dt by dr is C1 by R, means when R is more, dt by dr will be less, right? So the profile will be like this. Here R is more, here temperature is high, here temperature is low. It will be like this. Correct? Okay. So don't discuss that because that is not possible to visualize in the 2 dimension. But you must know that the profile is logarithmic. Okay? So please remember that R conduction is log of R2 by R1 by 2 pi KL. This is the second thing that you have to remember here. Q is equal to delta, no, don't write delta T, T1 minus T2. Sometimes delta T को आप लोग final minus initial लिख देते हो, तो T2 minus T1 लिख दोगे. Everything should be positive here, right? Then only Q will be positive. Log of R2 by R1 by 2 pi KL. ये याद रखना यार, ये बहुत जरूरी है, ये भूलने वाली चीजों में से नहीं है. This was the 4th case where temperature profile we had in a hollow cylinder without any heat generation, but the profile was definitely non-linear logarithmic. ठीक है, आगे बढ़ते हैं. देखो मैथमेटिक्स से कहीं नहीं डरना है, मैंने मैथमेटिक्स कभी याद नहीं करी, बट व्हेनेवर आई प्रूव एवरी टाइम आई गेट द रिजल्ट। बस आपको यही देखना है कि जब भी आप ये प्रूफ करने बैठो आपका रिजल्ट आया है कि नहीं आया। नो नीड टू मेमोराइज ऑल दिस C1 C2 मेथड्स, नो नीड टू मेमोराइज दीज थिंग्स। बस बेसिक मैथमेटिक्स क्या आपको आ रही है, व्हेनेवर यू आर अप्लाइंग, व्हेनेवर यू आर सॉल्विंग ऑल दिस प्रॉब्लम्स, आर यू एबल टू गेट द सेम आंसर एवरी टाइम? इफ यस देन फाइन, छोड़ो, फिर 4 दिन बाद फिर से कर दूंगा, फिर 10 दिन बाद फिर से कर दूंगा, इतनी बार करूंगा कि ये डेरिवेशन कभी मुझसे दोबारा गलत होनी नहीं चाहिए, ठीक है। एंड डेरिवेशंस करनी है ना, जो डेरिवेशंस मैं यहाँ पे करा रहा हूँ, मैं कोई भी फालतू डेरिवेशन नहीं कराऊंगा आपको। इफ आई फील लाइक दैट इज वेस्ट ऑफ टाइम, आई वोंट डिस्कस इन क्लास, ठीक है। सो लेट्स टेक the fifth case, which is the hollow cylinder, not hollow cylinder, which is a cylinder with heat generation. Please let me tell you one more pattern. आपने देखा होगा, whenever there is heat generation, we take a solid body, right? We don't take hollow cylinder with heat generation. You won't find. Rarely you find that there is a hollow body with heat generation. Heat generation cases are discussed generally in solid bodies. So fifth example is temperature profile in solid cylinder with heat generation. तो सिलेंडर आपका सॉलिड हो या फिर होलो, जो कंडक्शन की इक्वेशन है वो सेम है विथ हीट जनरेशन। हीट जनरेशन, अब हीट जनरेशन पे जितने डिस्कस मैंने स्लैब में करी है वो यहां नहीं करूंगा, बस टेम्परेचर प्रोफाइल डेवलप करेंगे। एंड अगेन आई विल प्रूव दैट Q विल बी अ फंक्शन ऑफ लोकेशन R, करेक्ट। सो फ्रॉम वेयर टू स्टार्ट, देयर इज द सॉलिड सिलेंडर, ठीक है। ऐसे एग्जांपल कहां मिलेंगे? करंट कैरिंग वायर, right? You can calculate that in a current carrying wire how much heat is being generated, right? This is a solid cylinder, fine. In this cylinder, the radius is R, fine. The diameter, the length is L, the radius is R, correct? ये चीजें हैं, and there is a uniform source of heat generation. So what are the assumptions? Steady state, अब मैं short में लिख रहा हूँ, uniform volumetric rate of heat generation, volumetric रेट ऑफ हीट। तो स्लैब में तो 2 वॉल होती हैं, सिलेंडर में वॉल नहीं होती। एक अगर सॉलिड सिलेंडर है, देयर इज ओनली वन सरफेस, एंड इफ देयर आर नो वेरिएशंस इन थीटा डायरेक्शन, देन एंटायर वॉल शुड बी प्रेजेंट एट द सेम टेम्परेचर। यूनिफॉर्म वॉल्यूमेट्रिक रेट ऑफ हीट जनरेशन, हीट स्फीयर और सिलेंडर का मैं फटाफट कराऊंगा, बिकॉज इसमें ज्यादा प्रोफाइल ग्राफ तो मैं बना नहीं सकता, है ना, इट्स नॉट पॉसिबल। सो यूनिफॉर्म वॉल्यूमेट्रिक रेट ऑफ हीट जनरेशन विच इज QG. What is the unit of QG? Energy by time by volume. बार बार बता रहा हूँ, ध्यान रखना। Second, heat transfer in radial direction. Third, heat transfer in radial direction only. Heat transfer in radial direction only. ये सारे डेरिवेशंस बिल्कुल एक ही जैसे हैं, ठीक है। तो आप तो बस फटाफट इसको करते चलो। फोर्थ, लेकिन बस मैंने कुछ बातें जो बताई है हीट जनरेशन में, वो हमेशा ध्यान रखनी है हीट जनरेशन की। अभी मैं हीट जनरेशन की बात और करूंगा जब मैं साथ में कन्वेक्शन भी ले आऊंगा, कंबाइंड कंडक्शन एंड कन्वेक्शन। बट एक बार थोड़ा सा सिर्फ कंडक्शन और देन हीट जनरेशन देख लेते हैं, है ना। अभी एक पॉइंट मैंने मिस किया हुआ है, जानबूझ के मिस किया, उसको थोड़ा सा आगे बताऊंगा, डोंट वरी। फोर्थ इज K इज नॉट अ फंक्शन ऑफ टेम्परेचर। फटाफट इंटीग्रेट करो। 1/R R dt, 1/R del by del R or d by dr, 1/R d by dr of R dt by dr plus Qg by K, because there is now generation, is equal to 0, right? ठीक है, so minus Qg by K, so minus Qg R by K, so I can write d by dr of R dt by dr is equal to minus Qg R by K। चलेगा, इंटीग्रेट कर देते हैं। R dt by dr is equal to minus Qg R स्क्वायर बाई 2K, ये R नीचे गया तो dt by dr इज इक्वल टू दिस डिवाइडेड बाई R, ये बन गया Qg इंटू R बाई 2K। चलेगा, फिर से इंटीग्रेट करते हैं, जस्ट अ मिनट। Qg R स्क्वायर बाई 2K प्लस C1, राइट, करेक्ट। जस्ट R dt by dr इज इक्वल टू R स्क्वायर बाई 2 प्लस C1, ठीक है। नाउ dt by dr इज इक्वल टू Qg R स्क्वायर 2K प्लस C1। दोबारा इंटीग्रेट करते हैं, T इज इक्वल टू माइनस Qg इंटू R स्क्वायर बाई 4K, बिकॉज दिस R स्क्वायर बाई 2 बिकम्स R स्क्वायर बाई 4K प्लस C1R प्लस C2, ठीक है। बहुत सिंपल सी बात है, बस अगर आपको ये इक्वेशन से याद है, कोई इसमें दिक्कत वाली बात नहीं है, राइट। अगेन इट इज हीट जनरेशन, So the whatever I told you, E generated, E out is same. One more assumption. The outer surface, this outer surface is maintained at TW or TS, surface temperature out, wall temperature कह सकते हो. Outer surface is maintained at TW temperature. Outer surface is maintained at TW temperature. शुरू हो जाओ, डेरिवेशन कर दिया है ना. अच्छा, one more thing, that in this case also there will be case of symmetry. Why? Because entire outer surface is present at the same temperature, so there will be a case of symmetry. If symmetry will be there, then obviously C1 must be. ऐसा मैं क्यों बोलता हूँ, if symmetry is there then C1 is 0. आपने ग्राफ में, बेसिक्स ग्राफ में पढ़ा था हाई स्कूल में. If you put x is equal to minus x and equation remains same, it means your graph is symmetrical about y-axis. If you put y is equal to minus y and your equations remain same, then your graph is symmetrical about x-axis. Obviously, if I want this graph to be symmetrical, ये r का टर्म यहाँ पे नहीं होना चाहिए, because then if I put r is equal to minus r, equation won't remain same. So for the symmetrical graph, C1 will always be 0. Fine. So yeah, from the condition of symmetry, ठीक है. और वो सिमेट्री किसके अबाउट होगी? दिस सिमेट्री विल बी अबाउट द लाइन r इज इक्वल टू 0. इसके अबाउट में जो प्रोफाइल बनेगी वो प्रोफाइल सिमेट्रिकल होगी. ठीक है. सो r इज इक्वल टू 0 के अबाउट आपको सिमेट्रिकल प्रोफाइल मिलेगी. फ्रॉम द कंडीशन ऑफ सिमेट्री C1 मस्ट बी 0. ठीक है, ये सीख लो, ये चीजें सीख लो डेरिवेशन में कि अगर if a function is symmetrical about y-axis, then when you put x is equal to minus x, the equation should not change. In this equation also, if you put r is equal to minus r, if this r is there, then the equation will change. If I want this to be symmetrical, and it will be symmetrical because the entire surface, outer surface is maintained at TW, so C1 is equal to 0. From this equation, we also know that at r is equal to capital R, T is equal to TW. So I also have at r is equal to capital R, T is equal to TW. लिख डालो सारा, है ना, put the value. So TW is equal to minus QG R square by 4K, and the C1 तो 0 है, plus C2, तो C2 की वैल्यू क्या आ गई? C2 is equal to TW plus QG R square by 4K. समझ आया? ठीक है. और क्या इक्वेशन लिख सकते हैं? Let us write the equation. This is the T temperature profile. C1 is 0, so I have the equation as T is equal to minus QG R square by 4K small k plus C1 is 0 and C2 is TW plus QG R square by 4K. You have this equation as T minus TW is equal to QG R square by 4K into 1 minus R square by capital R square. If you compare this equation and the equation that we got in case of solid cylinder without any heat generation, no, solid slab with heat generation, it is exactly same, बस 2K की जगह 4K आ गया. और अगर मैं एक और काम कर दूं, you know that inside this solid cylinder heat generation is taking place, maximum temperature will be here. Maximum temperature कहाँ पे exist करेगा? Along the axis, जहां से सिमेट्री होगी. तो if R is 0, T will be T max. So I can write one more equation, T max minus TW is equal to QG R square by 4K. और अगर मैंने इन दोनों को डिवाइड कर दिया, then what I'm getting? You can see here, T minus TW by T max minus TW, ये कैंसिल हो जाएगा, is equal to, now ये क्या हो गया? ये तो exactly same equation आ गई जो पहले आई थी, 1 minus x square by L square. Instead of L यहाँ पे R है ना, because it is the direction of heat transfer. Now we have T minus TW is equal to exactly same equation. ठीक है. एक और चीज, अच्छा यहां पे भी because the system is at steady state, because the system is at steady state, अगर सिस्टम स्टडी स्टेट पर है, it means whatever energy is being generated in the system, that must leave the system through the walls. राइट. सो कितनी एनर्जी जनरेट हुई है आप करके देख लो, कितनी एनर्जी जनरेट हुई है? QG इज द रेट ऑफ हीट जनरेशन. सपोज अगर मैं पूरे सिलेंडर की बात करूं, QG इज एनर्जी बाय वॉल्यूम बाय टाइम. आई वांट एनर्जी बाय टाइम, So you'll say that multiply this by volume. What is the volume? Volume is pi r square L, right? And it will be equal to minus Ka, the heat leaving by conduction through this outer surface. So that, और आप देखोगे it must, this is E generation. E generation. What is E leaving? कितनी एनर्जी लीव कर रही है? दैट इज माइनस के ए. व्हाट इज ए? एरिया, आउटर एरिया से कितनी एनर्जी लीव कर रही है? दैट इज 2 पाई आर. ये होगा ना ए, 2 पाई आर और 2 पाई आर एल, 2 पाई आर एल, 2 पाई आर एल इंटू डी टी बाई डी आर. और डी टी बाई डी आर कहाँ पे? डी टी बाई डी आर एट आर इज इक्वल टू कैपिटल आर. व्हाट इज डी टी बाई डी आर? देखिए ये रहा डी टी बाई डी आर, और C1 तो 0 था, तो माइनस क्यू जी आर बाई 2 के पुट कर देते हैं. सो ई लिविंग, ई लिविंग कितना आएगा? माइनस के 2 पाई आर एल. डी टी बाई डी आर कितना आ रहा है? माइनस क्यू जी कैपिटल आर 2 के. देखो भाई क्या आ रहा है, देखो के कैंसिल हो गया, 2 कैंसिल हो गया. क्यू जी पाई आर स्क्वायर एल, क्यू जी पाई आर स्क्वायर एल, सेम आंसर. ई लिविंग इज इक्वल टू ई जनरेटेड. स्टडी स्टेट पे होना भी चाहिए. वन मोर थिंग, the same way I utilized in case of plane wall with heat generation, वो मैं यहां भी कर सकता हूं. I can consider an imaginary surface. देखिए इसको मिटाते हैं फिर से. Okay, that I can also apply here. I can also apply in case of spherical shell. Suppose this is a cylinder, right? This is a hollow, this is a solid cylinder. बनाते हैं cylinder. Okay, लीजिए ये cylinder बना, ठीक है. आ जाओ भी देखो ये सिलेंडर बना. सपोज आई एम, दिस इज द एक्सिस, दिस इज द एक्सिस. आई एम कंसिडरिंग एन इमेजिनरी सरफेस. ये मैंने एक इमेजिनरी सरफेस कंसिडर किया, इमेजिनरी सरफेस. ओके, दिस इमेजिनरी सरफेस आई कंसिडर्ड एट अ डिस्टेंस ऑफ r is equal to small r from the axis of the cylinder, right? What is this distance? This distance is small r. अब मैं बोलूं कि अगर एट स्टडी स्टेट, अगर स्टडी स्टेट है तो इतने वॉल्यूम में, कितने वॉल्यूम में? इतने वॉल्यूम में जितनी एनर्जी जनरेट होगी, द अमाउंट ऑफ एनर्जी विच इज जनरेटेड इन दिस स्मॉल वॉल्यूम. भाई मैंने एक सरफेस क्रिएट किया तो एक वॉल्यूम बन गया ना. आई हैव क्रिएटेड दिस इमेजिनरी सरफेस. नाउ इनसाइड दिस सरफेस देयर इज अ वॉल्यूम. इन दैट स्मॉल सरफेस द अमाउंट ऑफ एनर्जी विच इज बीइंग जनरेटेड मस्ट बी इक्वल टू द अमाउंट ऑफ एनर्जी विच इज लिविंग दिस सरफेस बाय कंडक्शन. ठीक है, तो एनर्जी जनरेटेड इज इक्वल टू एनर्जी लिविंग बाय कंडक्शन अकॉर्डिंग टू द स्टडी स्टेट कंडीशन. तो अप्लाई कर दीजिए स्टडी स्टेट कंडीशन. व्हाट इज एनर्जी जनरेटेड इन दिस स्मॉल वॉल्यूम? Qg is the volumetric rate of heat generation that multiplied by pi r square into L. ठीक है, yes, this is the energy generated. What is energy leaving? You know that यहाँ पे भी एनर्जी कैसे लीव कर रही है? By conduction only. Here also it was leaving by. देखो इसके बाहर क्या हो रहा है? There is a medium, there must be convection. I am not talking about that. अभी मैं बाहर गया ही नहीं, अभी तो बस surface तक हूँ. Here everything is taking place by conduction. So what is conduction? What is the formula? Yes, minus Ka. Minus K. What is area? What is the area? Don't write capital R. I am talking about this. So 2 pi RL into dt by dr. And dt by dr at R is equal to small r. Because ये तो कोई भी variable R हो सकता है ना. R is equal to small r. Put the value. So this is Qg pi into L R square. dr को इधर ले जाइए. R square dr is equal to minus 2 pi K. एक R कैंसिल होगा ना आपका. दिस R विल बी कैंसिल्ड. सो R dr कर लेते हैं इसको. R dr माइनस 2 पाई K L dt. नाउ dt की लिमिट लगा दीजिए. dt की लिमिट कहां से लगेगी और dr की लिमिट कहां से लगेगी? व्हेन R इज 0 to R. This is from where 0 is, this temperature is Tmax. Tmax 2 at R temperature. The temperature must be some random temperature T. लिख लो. अब कर दो इंटीग्रेट. इफ यू इंटीग्रेट दिस इक्वेशन आई हैव द रिजल्ट. आइए लिखते हैं, मिटा दें, है ना. नोट करते रहना, पॉज करके नोट करते रहो. नोट क्या करना है? डिराइव कर लो. ये मैं प्लेन वॉल में बता चुका हूं, सिलेंडर में कर सकते हैं. चलिए, दैट इज Qg पाई L R स्क्वायर बाय 2. सो Qg पाई L R स्क्वायर बाय 2 इज इक्वल टू राइट हैंड साइड इंटीग्रेट T माइनस T मैक्स लिख दूंगा. T मैक्स माइनस T. सो 2 पाई KL, 2 पाई KL T मैक्स माइनस T लिख दिया. अब एक काम करो, कैंसिल करते हैं. पाई पाई कैंसिल, L L कैंसिल. ठीक है. सो व्हाट इज द इक्वेशन लेफ्ट? 4K. सो Qg R स्क्वायर 4K इज इक्वल टू टी मैक्स माइनस टी, ये शायद मैं पहले भी निकाल चुका हूं, टी मैक्स माइनस टी. सो टी मैक्स माइनस टी इज दिस, राइट? इफ यू पुट टी इज इक्वल टू टी डब्ल्यू, टी मैक्स माइनस टी डब्ल्यू, देन आर शुड बी कैपिटल आर, क्यू जी आर स्क्वायर बाई 4k. ठीक है, same equation I can write, right? I can write the same equation. So even without writing all those balance equation, आप सीधा एनर्जी बैलेंसेस मैं हर जगह प्रूफ करके दिखा रहा हूं. Energy balance is valid everywhere. Fine. So this was the fifth case when there was the temperature profile in a solid cylinder with heat generation. Now, according to our sequence, the sequence which we have developed, according to that sequence, the next topic should be sphere, holosphere. Holosphere without heat generation and solid sphere with heat generation. सर आप होलो में heat generation क्यों नहीं लेते? प्रॉब्लम हो जाएगी भाई. क्या प्रॉब्लम हो जाएगी? If I take hollow cylinder with heat generation, then when I write the volume, अब देखो भाई अगर होलो सिलेंडर है, इट्स लाइक दिस होलो सिलेंडर, अब हवा है बीच में, तो हवा में एनर्जी जनरेट तो नहीं होगी, एनर्जी विल बी जनरेटेड इन द बॉडी. सो I'll have to calculate the volume of that hollow cylinder by taking the volume of the total cylinder and subtracting the annular space, not annular, the inner space. So थोड़ी सी complexity आ जाएगी. So whenever there is heat generation, we normally take solid bodies. If there is no heat generation, we can take hollow bodies. Fine, मिटा दे, छठे केसेस में बढ़ेंगे. So temperature profile in a hollow sphere and then temperature profile in a sphere with heat generation. नोट कर लो सबसे पहले. Next is the spherical shell and the temperature profile in a spherical shell. Hollow spherical shell. Shell की बात, जब shell बोला इसका मतलब hollow. ठीक है? So sixth case लेते हैं. Sixth is temperature profile. Temperature profile in a hollow spherical shell. Again the same four assumptions, 4 or 5 whatever, right? So if a hollow shell is there, I am assuming that the inner surface is at a higher temperature, the outer surface is at a lower temperature, and hence the heat transfer is taking place from the inner to the outer temperature, to the outer surface. Okay, sphere, so it is a shell, so inner space is having some kind of source, can be a fluid. Okay, this is inner surface which is at a higher temperature T1, this is outer surface which is at a lower temperature T2. Assuming this is to be the center, and let's say that this is R1, this is R2. Again, it's a problem where area is increasing in the direction of heat transfer. If T1 is more than T2, I can say that this is the direction of heat transfer. Okay, this is the Q. Okay, so कहाँ से शुरू होगी चीजें? जो आपको इस इक्वेशन बताई थी, पहले assumptions लिख लेते हैं. First assumption is again steady state. Second assumption, K is not a function of temperature. Fine. Third assumption is what else? K is not a function of temperature. Yeah, radial direction. Heat transfer in R direction only, radial direction only, and no heat generation. Fourth, no heat generation. This is my sixth case. कहाँ से स्टार्ट करेंगे? फटाफट शुरू करना है. कहाँ से? देखो, आर स्क्वायर डी बाई डी आर, सॉरी इट इज 1 बाई आर स्क्वायर डी बाई डी आर ऑफ आर स्क्वायर डी टी बाई डी आर इज इक्वल टू 0. फाइन है ना? So 1 by r square d by d r of r square dt by dr. This is the equation when the heat conduction is in radial direction. From where to start? इसको r square को 0 ले उधर ले जाओ, हो गया 0. This becomes d by dr, r square dt by dr is equal to 0. Integrate it. R square dt by dr is equal to c1. dt by dr is equal to c1 by r square. Again integrate. dt or t is equal to c1 by r square. Integral is minus c1 by r plus c2. ठीक है क्या? राइट. दिस इज द टेम्परेचर प्रोफाइल. क्या लगता है? लीनियर है? ऑफ कोर्स इट इज नॉन लीनियर. व्हाट इज द नेचर? t इज इक्वल टू c1 by r. किसकी इक्वेशन है ये? हाइपरबोलिक. ओके, सो नॉन लीनियर ऑफ कोर्स, एंड इन नॉन लीनियर विच कैटेगरी? इन नॉन लीनियर इट इज हाइपरबोलिक. y इज इक्वल टू 1 by x is hyperbola, right? Rectangular hyperbola. So this is hyperbolic in nature. So आपको ये पता लगा कि when there is no heat generation in slab, the profile is linear. When there is no heat generation in cylinder, the profile was logarithmic. When there is no heat generation in sphere, the profile is hyperbolic. Okay. So after this, T आ गया. अब C1 और C2 पता कर लेते हैं. So again, outer surface and inner surface are there. So how to write C1 and C2? We have two boundary conditions. So at R is equal to R1, T is equal to T1. So I have this equation. T1 is equal to minus C1 by R1 plus C2, and T2 is equal to minus C1 by R2 plus C2. दोनों को subtract करेंगे. I have the equation T1 minus T2. T1 minus T2 is equal to minus C1 by R1 minus C1 by R2. So that becomes C1 by R2 minus C1 by R1, and C2 cancels. कितना आ जाएगा? T1 minus T2 is equal to C1 R1 minus C1 R2. So C1 into R1 minus R2 by R2 R1. चलेगा? That is C1. So C1 is equal to T1 minus T2 into R1 R2 divided by R1 minus R2. हो गया. ठीक है? Same thing. Now C2. How to find C2? Use any one of these equation. So C2 is equal to T2 minus C2 is equal to, ये C1 C2 की वैल्यू याद रखनी क्या? नहीं, this is just mathematics. C2 is equal to T2 minus this or T2 plus C1 by R2. So that becomes T2 plus this is C1 divided by R2. So this becomes T1 minus T2 into R1 divided by R1 minus R2. यही बनेगा. ठीक है ना? T2 plus C1 by R2. So R2 cancel. So I have C1, I have C2. Now I can write the temperature profile equation. It gives you T is equal to minus C1 by R. This divided by R. So T1 minus T2 R1 R2 divided by R1 minus R2 into R. This is minus C1 by R. Huh? So I'll write here T2 minus T1. चलेगा? T2 minus T1. Okay. Plus C2. And what is C2? C2 is this. T2 plus T1 minus T2. Okay, T1 minus T2 into R1 by R1 minus R2. Correct? So, can we take something common? Let's see. So, I can write this equation as, this is not in the denominator, this is separate. Okay. And this T2 is separate. So I can write this equation as T minus T2 is equal to T minus T2 is equal to T2 minus T1 by R1 minus R2. T2 minus T1 can be taken out. R1 minus R2. Various ways of writing the same equation are possible. T2 minus T1 by R1 minus R2. एक काम करते हैं, R1 R2 को भी कॉमन ले लेते हैं. R1 R2, let's see what is remaining. T2 minus T1 by R1 minus R2 into R1 R2. So what is left? 1 by R, correct? Plus this is T1 minus T2. So I can write minus R1 कॉमन ले लिया, R1 minus R2 कॉमन ले लिया. क्या कॉमन लिया इधर? R1 R2 कॉमन लिया. So it should be 1 by R2. ठीक है क्या? देखो एक बार कॉमन ठीक से लिया, राइट? R1 R2 कॉमन ले लिया. So this is R1 R2 by R and this is R1, correct? Negative sign is there, so T2 minus T1 becomes T1 minus T2. Yes, everything is fine. This can be written as T minus T2 by T minus T2 by T2 minus T1. इसको और भी फॉर्म्स में आप लिख सकते हो. R1 R2 by R1 minus R2 1 by R. ये भी फॉर्म में आ जाएगा. R2 minus R उस फॉर्म में आ जाएगा, बट इट्स ओके. R2 इस फॉर्म में है ना. I R2 देखते हैं और क्या सिंप्लीफाई होगा. देखो ठीक है, आप इसके बाद इसको फर्दर सिंप्लीफाई करते रहो। इसको याद रखना है क्या? नहीं, बस आपको याद रखना है कि हाइपरबोलिक है, ठीक है, इसको याद नहीं रखना। ये बस आपकी तसल्ली के लिए कि मुझे फाइनल रिजल्ट तक जाना था। इट कैन बी रिटन इन वेरियस वेज। आई कैन राइट दिस इक्वेशन एज R2 minus R divided by R2, then R2 will be cancelled, then it will be R1 by R into R2 minus R divided by R1 minus R2 can be one of the form of equation. So it can be simplified in various ways. Now the thing arises that what is Q? So Q के बारे में देख लेते हैं। Q is equal to minus K area. Area is the spherical surface area which is changing. Here spherical surface area is 2 pi R, 2 pi R2, R3, R4, R5. In various different surface areas. So minus, what is the surface area of a sphere? 4 pi r square. So 4 pi r square dt by dr. Correct? What is dt by dr? फिर से देखो, this is 4 pi r square, dt by dr is c1 by r square cancel, मतलब q क्या रहेगा? q won't change with r. Profile non-linear है लेकिन q is same because dt by dr is changing with this rate 1 by r square. Right, okay, so this is also r square, so you can write this equation as minus c1 by r square, and where is c1? This is c1, okay. So q is equal to minus k into 4 pi r square multiplied by c1 by r square dt by dr. r square cancel, we have c1 कहाँ पर है? c1 कहाँ पर है? ये रहा, t1 minus t2, ठीक है। नेगेटिव साइन को हटाने के लिए क्या करेंगे? t1 t2 को तो रहने देते, इसको कर देते हैं r2 minus r1, है ना। सो Q इज इक्वल टू 4 पाई के, करेक्ट, 4 पाई के एंड इनटू C1. व्हाट इज C1? R1 R2 into T1 minus T2. We always write in the form of high minus low, तो T2 minus T1 नहीं कर रहा, इसको मैं R2 minus R1 कर दे रहा हूँ, चलेगा ना? R1 minus R2 to remove this negative sign, R2 minus R1. From here what we can conclude is, you can write this equation in the form of resistance and driving force. So that is T1 minus T2 में लिख दे रहा, T1 minus T2 divided by R2 minus R1 by 4 pi k R1 R2. R2 minus R1, you can see that everything is constant here, right? And therefore Q is not a function of R. However, dt by dr is a function of R. Area is a function of R. K is constant. K is not a function of R. This is in the form of driving force by resistance. R2 minus R1 by 4 pi k R1 R2. Temperature profile बता दी, ठीक है। अच्छा, मैं ये suggest करूँगा that in all these cases also try to remember the dt by dr. In the previous case, it was C1 by R, it is C1 by R square. What can be concluded from this? C1 by R square inversely proportional to R and inversely proportional to R square means, what do you think? Inversely proportional to R means as R increases, dt by dx decreases. Inversely proportional to R square, right? तो मतलब क्या हुआ? इसका मतलब यहाँ dt by dr there will be more decrease in temperature as compared with the radius as compared to in case of in case of a cylinder. It was only C1 by R. But ultimately you can find that the Q was constant here. ठीक है, समझ आई होंगी चीजें। This was the sixth case, that was temperature profile in a hollow spherical shell. Now if I have to take, अब आपको ऑटोमेटिकली चीजें समझ आ गई होंगी। If I want to write for a solid, for a heat generation case, it has to be a solid sphere. ठीक है, note down everything, then will temperature profile in a solid sphere with heat generation. बस हम लोग प्रोफाइल डेवलपमेंट के एंड पे आ चुके हैं ऑलमोस्ट। इन अ सॉलिड स्फीयर, इन अ सॉलिड स्फीयर विद हीट जनरेशन, ठीक है, इन अ सॉलिड स्फीयर विद हीट जनरेशन, करेक्ट। सो असम्पशंस लिखेंगे एंड प्रोफाइल तो नहीं बनानी है वहां पे, बट आई वांट टू राइट सम इक्वेशंस। हाँ, प्रोफाइल भी लिखनी है, बट हाँ ओके, आई राइट द प्रोफाइल ऑल्सो बिकॉज प्रोफाइल विल बी ऑलमोस्ट सेम एज बिफोर। एक पैटर्न फॉलो होगा, लास्ट में इन सभी को कंक्लूड करेंगे। जो रिजल्ट्स याद रखने हैं वो रिजल्ट्स मैं आपको लास्ट में लिखवाऊंगा। विल मेक अ टेबल, दैट इज वेरी वेरी इंपॉर्टेंट, राइट। तो अब हीट जनरेशन आ गया बट सॉलिड स्फीयर है मेरे पास, फाइन। दिस इज द सेवेंथ केस ऑफ टेम्परेचर प्रोफाइल। सो almost a sphere. No. Okay. Right. So this is a sphere. In this sphere, it's a solid sphere, so I can't take an inner surface. That only thing I know is the surface is maintained at a temperature Tw, and there is a uniform volumetric rate of heat generation. First assumption, steady state. Second assumption, thermal conductivity is not a function of temperature. Third assumption, heat transfer in radial direction only. HT इन अब आप लोग सब सीख गए हो, फटाफट लिख लेते हैं, अब मैं ज़्यादा टाइम बिल्कुल नहीं लगाऊंगा. डायरेक्शन ओनली. और फोर्थ अजम्पशन, वॉल्यूमेट्रिक रेट ऑफ हीट जनरेशन QG is uniform volumetric rate of heat generation. Volumetric rate of heat generation. और क्या? Fifth. What is fifth? Outer surface is maintained at TW. Outer surface is maintained at TW temperature. Maintained at TW. कहाँ से शुरू करेंगे? TW temperature. From where to start? 1 by R square d by dr R square dt by dr plus QG divided by K equal to 0. ये सारी चीज़ें आपको बिल्कुल संगीत की तरह याद होनी चाहिए, क्योंकि देखो अगर एक तो देखो देयर आर टू प्रॉब्लम्स. आप यू आर फेसिंग अ क्वेश्चन, one problem you don't remember the formula, one problem you are not able to apply the formula, right? तो अगर याद ही नहीं होगा तो वैसे ही अप्लाई नहीं कर पाओगे. If you want to think that how to solve the problem, at least you should know the formulas. If you are going for a fight, at least you should have the weapons, है ना? If you are not able to remember this, how you are thinking that you will be able to develop, you will be able to solve a new kind of problem. New kind of मतलब बहुत न्यू नहीं होंगी यार, चीज़ें तो वैसी रहती हैं. हम लोग तो LMTD भी गलत करके आ जाते हैं, ठीक है? So be careful while doing all those calculations and remember these things, these equations at least, right? So ले जाओ सारी चीज़ें उधर. d by dr r square dt by dr is equal to minus QG r square by K. Integrate r square dt by dr is equal to minus QG r cube by r square का इंटीग्रल क्या होता है? सीरियस 3 होता हो, ठीक है? आर क्यूब बाई 3K प्लस C1, ठीक है? डिवाइड dt बाई dr इज इक्वल टू माइनस QG r बाई 3K प्लस C1. इंटीग्रेट अगेन, t इज इक्वल टू माइनस QG r स्क्वायर बाई 6K प्लस C1r प्लस C2. चलेगा? नो, दिस वॉज C1 बाई r स्क्वायर, राइट? दिस इज C1 बाई r स्क्वायर. There I made a mistake. C1 by r square. What is the integral of C1 by r square minus C1 by r? So minus C1 by r plus C2. ठीक है ये. T is equal to minus QG r square by 6K minus C1 by r. ठीक है, okay, plus C2. That is the temperature profile. Obviously it is non-linear. ठीक है, it is non-linear. क्या करें आगे? From the condition of symmetry, this C1 has to be 0 again. है ना? C1 has to, because this entire term should vanish. Otherwise आप symmetry की condition लगा ही नहीं पाओगे. If the outer surface is maintained at the same temperature and heat generation is there, the temperature profile must be symmetrical. Okay? From condition of symmetry, from condition of symmetry, भाई यहाँ पे दो सरफेस तो है नहीं कि मैं बाउंड्री कंडीशन, देयर इज ओनली सिंगल सरफेस विच इज द आउटर सरफेस ऑफ दिस स्फीयर. अब दो सरफेस नहीं है कि मैं बाउंड्री कंडीशन लगाऊं दैट एट r इज इक्वल टू r1 दिस इज t1 एंड एट r इज इक्वल टू r2 दिस इज t2. ऐसा तो है नहीं. दिस इज द वन रेडियस r, सो आई हैव एट r इज इक्वल टू कैपिटल R, t इज इक्वल टू tw. बट बाय द कंडीशन ऑफ सिमेट्री, और यू कैन से दैट, कई बुक्स में ऐसा लिखा होगा dt बाय dr एट r इज इक्वल टू 0. दिस इज r इज इक्वल टू 0. तो यहाँ पे सिमेट्रिकल होगा ना, तो dt by dr will be 0. What is dt by dr? This. How this can be 0? Right? For this term to be 0, this must C1 term must be vanish. For dt by dr to be 0 at r is equal to 0, this C1 term should not be there. Right? This entire term should not be there, which is possible if C1 is 0. So from condition of symmetry, I can say from condition of symmetry, C1 is equal to 0. What is C2? very easily you can write C2 is equal to TW plus TW C2 and QG R square by 6K. ठीक है, C2 is equal to this. So what is the temperature profile? T is equal to minus QG R square by 6K plus TW plus QG R square by 6K. So I can always write T minus TW is equal to QG capital R square by 6K into 1 minus R square by R square. Same equation, बस 4K की जगह 6K आ गया. And you know that when R is 0, this here you'll be having maximum temperature. बिल्कुल पहले जैसा ही, सब कुछ पहले जैसा ही. When R is 0, you have maximum temperature. So you can also write T max minus TW is equal to QG. यहाँ पे 0 हो गया, 1 minus 0 is 1. So QG R square by 6K. If you divide the equation T minus TW, T max minus TW, ये देखो फिर से क्या हो गया? You are getting the same. This is dimensionless form. So this is again same as before. Correct? Right? So, and also again you can assume that there is an imaginary volume. Here also energy generated will be equal to energy leaving. So आप check करके देख सकते हो. For the entire volume of the sphere, वो मैं इसमें नहीं करा रहा, ठीक है. In the entire volume of the sphere, what is the energy generated? वो आप check करके देख सकते हो. Suppose this is a sphere, this is the center. I am considering an imaginary sphere. An imaginary sphere at a distance r, small r, correct? Now on this small r, what is the volume? 4 by 3 pi r cube. The energy generated, Qg, multiplied by 4 by 3 pi r cube, only just this much volume, fine, is equal to this leaving by conduction. This is 4 pi r cube is equal to leaving by conduction. What is the area? 4 pi r square dt by dr. Fine. What is dt by dr? dt by dr is this minus qg r by 3k. So minus qg into r by 3k. ठीक है क्या ये? qg r by 3k. Yeah. So that is the value of minus k dt by dr. Let's see what we are getting. 4 pi cancels, 3 cancel, and even r square and this cancel. I have the r cube is also minus ka dt by dr, which is 3k. What is this qg? Okay, I'll have to integrate now. I'm sorry. Sorry. We have to integrate. So this multiplied by dt by dr. Sorry, I should integrate here. dt by dr at r is equal to small r. So after this, what is left? 4 by 4 is getting cancelled. Pi is getting cancelled. So what do we have? We have qg by 3, right? R square will be cancelled. 4 will be cancelled. Pi will be cancelled, right? So what is left? R dr, right, is equal to minus k into dt, है ना? Integral. When temperature R is 0, it is T max, and then it is if R is capital R, it will be TW. If R is it is T, you should take here R. So R square by 2. So QG R square by 2 means 6, and this is K. This is negative. This is T minus T max. चेक करके देख लो कहीं से भी. TW minus T max करोगे तो ये the equation will be QG R square by 6. सेम इक्वेशन आ जाती है ना, तो यहाँ भी वेरीफाई हो गया. लिख लो इसको भी. Okay. So this was again the temperature profile for heat generation inside a solid sphere. 7 profiles we have done. Now what is the job? I'll make you a table for these 7 derivations and we'll write some noteworthy points. सारी चीजें मैंने लिखवा दी है, but now I'm going to compile them. I'm going to make a table and write all of those things. Table बना लेते हैं. Let us compile all these cases, the 7 cases what we have discussed. Let's see इस table में क्या क्या चीजें मैं आपके लिए summarize कर पाता हूँ. So just make the table. I'll be writing here the cases. The first case was flat wall, right? Without anything, without any special thing. That was the first case. ठीक है, यहाँ पे लिख लेते हैं, है ना? तो flat wall, just a flat wall. In the flat wall, what was the temperature profile? लिखने की जरूरत है टेम्परेचर प्रोफाइल, इट वाज लीनियर, राइट, लीनियर टेम्परेचर प्रोफाइल। इक्वेशन लिख पाएंगे, व्हाट इज द इक्वेशन, आप इक्वेशन तो लिख सकते हो ना, कांट यू राइट द इक्वेशन ऑफ अ स्ट्रेट लाइन, राइट, सो यू कैन राइट द इक्वेशन, ओके। अपार्ट फ्रॉम लीनियर, if you see Q was not a function of x, Q was constant, right? How to write Q in the form of driving force by resistance? Q was equal to T1 minus T2 divided by L by K into A, right? Steady state heat conduction through a wall. Temperature profile भी लिख ही लेते हैं, let's see what we can write here. So T is equal to कैसे लिखते हैं, y is equal to mx plus c ना, this was what was the slope of line, right? The slope of line was y2 minus y1 means t2 minus t1, देखो इस तरह से मैं याद रखता हूँ, t2 minus t1 divided by x2 minus x1 L minus 0, this was the slope, right, multiplied by x, but it should when x is L, I mean when x is 0, the temperature must be T1, right? So if you put x is equal to 0, it should be T1, so should be something like plus T1, I think. देखो, this should be the temperature profile, y is equal to mx plus c, सारी चीजें वेरीफाई हो रही है ना, when x was 0, t is equal to T1, when x is L, put the value, t is equal to T2, right, all, and the slope is T2 minus T1 by L. So this was the temperature profile, linear temperature profile. Q was constant, okay. Heat flux is this, right? Second, flat wall, fine, where K was a function of temperature, right? K was a function of temperature. K is equal to K naught into 1 plus beta into T, fine. So if beta was greater than 0 and when beta was less than 0, beta equal to 0 के लिए तो ये हो गया, when beta was greater than 0, what was the nature of the profile? You can make here two profiles, just एक बार इसको sum up कर रहे हैं, summarize कर रहे हैं, तो आप साथ में बना लो, right? This was the nature of profile when beta was greater than 0, fine, you can check. When beta was less than 0, this was the nature of profile, right? This was T1, T2, T1, T2, ठीक है? Of course, they were non-linear. Was Q a function of x? Q at various positions अलग-अलग था क्या? नहीं. We found the equation ना. Q was not a function of x. Fine. So Q was not a function of x. What was the expression for Q? Q is equal to K. So I can write this equation as T1 minus T2 divided by L by K mean, which was the arithmetic mean, multiplied by A. What about this case? I mean, this equation is valid in both the cases or only one case? What do you think? Same, both the valid in both of the cases. Find K is equal to T1 minus T2 by L by K m into A, valid for both the cases. And the temperature profile लिखने की जरूरत नहीं, it was a complex relation, so no need to write the temperature profile. Third case. Third case was flat wall, right, with heat generation. With heat generation, fine. So both sides were maintained at constant temperature. What was the nature of profile? I think it was parabolic. We discussed. It was parabolic. Fine. In this case, Q was a function of x. है ना? You can see Q was a function of x. Correct. Can you write this in this form? Can you write this Q in this form? I mean driving force by resistance. What was the value of Q? आपने Q निकाला था, क्या आप लिख सकते हो ड्राइविंग फोर्स बाय रेजिस्टेंस? लिख ही नहीं सकते, बिकॉज देयर Q इज अ फंक्शन ऑफ x. तो जब जनरेशन होगी, ये मैं आपको बता रहा था कि समथिंग वन पॉइंट आई मिस्ड डेलिबरेटली, व्हेन द हीट इज बीइंग जनरेटेड इन द सिस्टम, यू कांट राइट एज ड्राइविंग फोर्स बाय पोटेंशियल डिफरेंस बाय रेजिस्टेंस. व्हेन हीट जनरेशन इज देयर, यू कांट राइट द हीट रेट, हीट ट्रांसफर रेट एज, बिकॉज यहाँ देखो, यहाँ हीट ट्रांसफर रेट इज कांस्टेंट विद लोकेशन. तो चाहे आप यहाँ की बात कर लो, यहाँ की बात कर लो, हीट ट्रांसफर रेट इज सेम, सो आई कैन राइट हीट ट्रांसफर एज द ड्राइविंग फोर्स बाय सम काइंड ऑफ रेजिस्टेंस. आई कांट राइट हियर. ओके, what are the equations which you can remember here? I think the equation that is most important was the temperature profile, and then when we wrote the equation in the dimensionless form, I think it was T minus TW by T max minus TW is equal to 1 minus x square by L square, right? This was the equation, correct? And the equation was T minus TW is equal to Qg into L square by 2k 1 minus x square by L square. ये देख लेना, ये इक्वेशन थी T max minus TW was this, है ना? अगर भूल गए हो तो एक एलिमेंट ले लो, सरफेस इमेजिन कर लो, एंड देन अप्लाई द एनर्जी इन इज इक्वल टू एनर्जी आउट, करेक्ट? देन वी हैव फोर्थ केस, hollow cylinder. Hollow cylinder. What was the nature of profile? The profile was logarithmic. Was Q a function of x? No. If there is no heat generation, Q was not a function of x. Can I write like this? Yes, I can. Q dot is equal to T1 minus T2 divided by log of R2 by R1, log of R2 by R1 divided by 2 pi K into L. That was Q. टेम्परेचर प्रोफाइल की इक्वेशन लिखने की जरूरत नहीं है, ठीक है? Q was constant, प्रोफाइल was non-linear. अगर इतनी बातें आप याद रखो तो चलेगा. कुछ एक्स्ट्रा क्या याद रखना है? आप dt by dx की वैल्यू याद रख सकते हो कि dt by dx was C1 by R, आई थिंक, है ना? सो आप एक ये चीज यहाँ पे याद रख लेना कि dt by dr was proportional to, inversely proportional to R. That you can remember. Then fifth one was solid cylinder with heat generation. So whenever there will be heat generation, never write your Q like this, because in that case Q is a function of x. Okay, even then resistance won't be constant, right? So don't write like this, because ये जो formulas मैंने आपको बताया ना, L by Ka is the resistance for a solid. Now suppose there is a solid wall, heat generation is taking place, and you are writing resistance as L by Ka. You can't do that. This formula was derived when there was no heat generation. Okay, so solid cylinder with heat generation. With generation. What was the profile? Okay, profile we don't know. It was non-linear, of course. Okay, was Q a function of x? Yeah, Q was a function of x. Can you write like this? No need to write like this. Okay, what you can write here, what you can remember here is the equation. It was again T minus TW by T max minus TW is equal to 1 minus R square by capital R square, correct? And the equation was T minus TW is equal to Qg into R square by 4k. देखो ये पैटर्न है, Qg L square by 2k, Qg R square by 4k, Qg R square by 6k into 1 minus R square by capital R square. That was for solid cylinder with heat generation. Sixth case was a sphere, hollow sphere without any heat generation. लिखते चलो, है ना? Sixth case was hollow sphere without any heat generation. तो sixth case लेते हैं, hollow sphere without heat generation. That is the sixth case. Hollow sphere. What was the nature of profile? Hyperbolic. Hyperbolic. Was Q a function of x? No, Q was constant with x, so Q was not a function of x. Whenever there is heat, can you write like this? Yes, T1 minus T2 by 4 pi k R1 R2 divided by, now there was R2 minus R1 by 4 pi k R1 R2, I think, right? Yes, it was R2 minus R1, R2 minus, this is the resistance, 4 pi k R1 R2. What else I can write? Temperature profile नहीं लिखनी है. Again, it was complex. Okay. Then seventh case, sphere with heat generation. Sphere with heat generation. That is profile non-linear. No need to write, but yes, Q was a function of x. No need to write like this. Okay. This equation you can write that T minus TW. T max minus TW. ये डिफरेंस कई बार पूछ लेते हैं, सो इसलिए मैं बार बार लिखवा रहा हूँ, ये इंपॉर्टेंट है. व्हाट इज द डिफरेंस बिटवीन मैक्सिमम एंड वॉइड टेम्परेचर? दिस वाज अगेन इक्वल टू 1 minus R square by capital R square, and T minus TW was also equal to Qg आर स्क्वायर बाय 6k इंटू 1 माइनस आर स्क्वायर बाय कैपिटल आर स्क्वायर। ठीक है, तो ये टेबल बना के आपने सारी चीजें समराइज कर ली। ठीक है, आपको जो हीट जनरेशन जो प्लेन वॉल में हुआ था वहाँ जितने पॉइंट्स बताया था दे आर वेरी इंपॉर्टेंट। आई टोल्ड यू दैट वन केस आई विल डिस्कस इन न्यूमेरिकल्स वेयर द सरफेस टेम्परेचर्स आर नॉट मेंटेन्ड एट सेम वैल्यूज। उसकी डेरिवेशन भी कर सकते हो, दैट इज नॉट अ बिग डील। आप चाहो तो ट्राई करके टेम्परेचर प्रोफाइल निकाल सकते हो, बट मैंने आपको बताया कि वहाँ टेम्परेचर प्रोफाइल याद नहीं रखनी। नोबडी इज गोइंग टू आस्क यू द टेम्परेचर प्रोफाइल इन दिस केसेस। Okay, so that's all about the derivation of temperature profiles. What is the next topic? The next topics in the upcoming classes will be the combination of conduction and convection, when simultaneous conduction and convection is taking place, and we can talk about composite bodies, and we can talk about the overall heat transfer resistance, क्योंकि overall heat transfer resistance की बात करने के लिए पहले मुझे convection के बारे में थोड़ी सी बात करनी होगी।